Two quantities vary together at a constant rate of change if changes in one quantity's value are proportional to changes in the other quantity's value. So for example, x and y vary together at a constant rate of change of, say, 3 if any time x changes by some amount, y changes by an amount that is 3 times as large, or the ratio of delta y to delta x will always be equal to 3. So one common example of a constant rate of change relationship is the idea of constant speed. And an object travels at a constant speed if the object's change in distance from some reference point is always the same number of times as large as the corresponding change in time from some reference time. So let's look at one example of this. Let's consider the following scenario. A car passes mile marker 54 traveling at 48 miles per hour, and the car maintains this constant speed. We'll let the variable t represent the number of hours since the car passed mile marker 54, and we'll let d represent the number of miles the car has traveled since passing mile marker 54. And we have a table of values relating t and d, and we can use this table to describe how t and d vary together over various intervals of time. So for example, if we imagine t increasing from 1 to 4, then we know that d increases from 48 to 192. And over this interval of time, the change in time is equal to 4 minus 1, which is equal to 3. And the change in distance is equal to 192 minus 48, which is equal to 144. And if we look at the ratio of the change in distance to change in time over this interval, we see that this ratio is equal to 144 divided by 3, which is equal to 48. And this ratio being equal to 48 literally tells us that over this interval of time, the change in distance is 48 times as large as the corresponding change in time. Or mathematically, delta d is 48 times as large as delta t. Now, if we look at another interval of time, so if we look from t equals 3 to t equals 5, we see that d varies from 144 to 240. And this change in time is equal to 2. The corresponding change in distance is equal to 240 minus 144, which is equal to 96 miles. Now, if we compute the ratio, again, if we compute the ratio of the change in distance to change in time, that will be equal to 96 divided by 2, which is again equal to 48. So this ratio over this other interval of time being equal to 48 tells us the same exact thing, that over this other interval of time, the change in distance is again 48 times as large as the change in time. Now, it doesn't matter what interval of time we look at. Since the car travels at a constant speed of 48 miles per hour, the ratio of the change in distance to change in time over any interval of time will always be equal to 48, which is the same thing as saying that the change in distance will be 48 times as large as the corresponding change in time. So we can use this way of thinking to actually answer some questions about how the car's distance changes over specific intervals of time. So let's look at this following question. How far does the car travel during the time interval from t equals 1.537 to t equals 2.859? Now, over this interval of time, the change in time is equal to the final time minus the initial time. So 2.859 minus 1.537. Now, since the car travels at a constant speed of 48 miles per hour, we know that the corresponding change in distance has to be 48 times as large as this change in time. So the change in distance is 48 times as large as 2.859 minus 1.537. We can use our calculator to actually compute this change in distance. So we see that over this interval of time, the car's distance from mile marker, whatever the mile marker was, is 63.456 miles. So we can say that over this interval of time, the car's distance changed by 63.456 miles.